When I think of things like immersive retail or spatial computing, or even some of the industrial IoT use cases that we've been talking about as the promise for edge computing for a while, I don't see how those applications run without this new type of density of being able to get really heavy traditional compute pieces closer and closer to the user and kind of getting away from the event-based lightweight computing that's at the edge today. And so, in my opinion, when we start thinking about the promise of edge computing, none of that really gets unlocked until you start having these types of compute primitives running on the edge of your network.
Hi, this is your host Supil Bhartiya, and welcome to another episode of TFI Let's Talk. Today we have with us Shawn Michels, VP of Product Management at Akamai. Shawn, it's great to have you on the show.
It's great to be here. Thanks for having me, Swapna.
It's my pleasure to host you here. And today we are going to talk about Gecko, a new announcement that you folks made, which stands for Generalized Edge Compute. Of course, there are a lot to talk about today, but let's start with this announcement. What it is, what does it do, and then of course we'll go in details.
We're really excited about Gecko, and I think in order to understand kind of why we're excited about Gecko, it makes sense a little bit to rewind about why Akamai is in the cloud computing space in the first place. And when we entered the market, we really took a look at kind of the way that cloud architectures were evolving. And we saw that in terms of cloud applications and cloud architectures, there was this need to change in the way that you approach infrastructure in order to enable this next generation of what we call edge native applications that are designed to really start pushing the experience and data closer to the user in order to improve performance and to reduce latency. And so when we originally entered the market and we acquired Linode, the idea was that we wanted to take Linode's very easy to use, simple primitives and deploy them on Akamai's leading network and our Akamai's leading global network. And so if you think about what we did last year, we really spent a lot of our time building out what we call these core computing regions. So when we acquired Linode, they had 11. We had added an additional 13 for a total of 24 core computing regions across the globe. And really what those core computing regions are about really big, heavy, dense computing type applications. So similar to what you would run in a traditional hyperscaler. And as we're looking at these cloud native architectures, things like data warehouses aren't going away. The ability to need big kind of compute isn't going away. And we wanted to make sure that we had an infrastructure layer available to customers who needed that part of the application. However, the second part was really what we're starting to see with Gecko, which is taking certain elements of a traditional computing layer and making sure that we can now get those into 100 plus locations around the globe. So taking VM infrastructure and being able to give that to our developers on top of our global platform to really reach users and to develop new types of experiences that didn't exist before. So what's exciting about Gecko is it kind of takes a look at what's kind of wrong with existing core computing architectures, takes a look at kind of what the CDNs are doing and saying, okay, well, maybe that's not quite heavy enough, and creating a layer in the middle that really allows us to build these new next generation edge native applications and experiences.
I just want to understand, or for the viewers to understand, the difference between the centralized cloud model and this distributed or decentralized computing model that you folks are building.
Yeah, I think that makes a lot of sense. And I think the best way to do it is probably in the illustration of a use case that we actually talked through with one of our retail customers. So we were approached by a retail customer who wanted to dynamically personalize the website based off of what users were doing inside of the store. So imagine a situation where a user is navigating across the application. The website wanted to basically say, I want to take the user's previous purchase history and I want to use that information in order to dynamically signal and kind of get to them new offers, new discounts, or even put new products in terms of the experience in front of the user as they're navigating in real time. And so when you start thinking about how you piece together that application, you need a couple of components to come together. So on one hand, you need JavaScript running at the edge or some kind of traditional edge computing technology that the CDNs have typically provided in order to kind of capture the click information and kind of capture what the information the user is doing, and then sending that data somewhere in order to get processed for the recommendation. And so this particular retailer had a data warehouse running in AWS West. And what they found is that they could capture the information about what the user was doing. They could send it to AWS West to get processed. But by the time it was processed, there was so much latency injected into that decision making, just taking it from wherever the user was and sending it to AWS West, that the user had clicked away and they couldn't get the returns in time in order to be able to offer that customized experience. And so what we're seeing in these more decentralized applications and these decentralized architectures is the recognition that in order for an application like that to work, what you really need is kind of a middle layer. So still have all your heavy data processing running inside of a data warehouse in AWS West, but what this retailer is looking to do with a new Gecko-like system is to say, okay, well, I'll now create a data cache in 20, 30, 40 locations around the globe. And I'll also enable that data cache layer to have some intelligent processing so it can make decisions about what to show to the user. So now when an end user is clicking on a piece of content, you have the kind of the edge layer capturing the information, but rather than going to the big centralized data center, it's going to this more distributed data center so it can quickly make a decision and then give a recommendation within the latency that the user is expecting. And so what's really cool about that is while that's kind of a start, you can see that is kind of a personal recommendation for an e-commerce site or a retail site, but it's also very similar to model to what we're seeing with large language model training and AI inferencing, where models are being trained in a big centralized facility, but then being sent out closer to the user to actually be run within the latency thresholds of the application or the service. And I think it's that combination of saying not all applications run in the core, not all applications run in the distributed layer, not all applications run at the edge, but it's the integration of all of those different layers is what really we think the next generation of application needs. And it's that combination where we think Akamai's approach to the cloud really stands out relative to others in the space.
And that also kind of takes me back to the very, very old days of when we talk about, very monoculture. It was, we did not talk about the hybrid like it was. I'm talking about the Windows and Linux, where it was like, we are heterogeneous. Then you talk about homogeneous. So as we are moving forward, of course, we can talk about, the monoliths. In some cases, Amazon was last year, and they're like, we are going back to monoliths. For a certain use case, that was not a mandate on microservices versus monoliths. But the whole point is that as the world is evolving, it will be again very, very hybrid. We will be leveraging data centers will be there, centralized cloud will be there, edge will also be there, and then of course with LLMs and progression in 5G technologies, private 5G network, this will become even more fine-grained, more gourmet kind of solutions where, and also we have not even touched about data sovereignty. We also hear a term called techno-nationalism, where a lot of companies, countries are moving there. So can you just take a holistic view and look from a broader perspective that the direction that Akamai is moving? I mean, of course, you folks acquired Linode, which kind of predates, AWS when it comes to public cloud. CDN, you folks have been doing it before anybody else. So once again, we are setting pieces for a puzzle for the word that we have not even seen that word is being built. But when the piece is in place and 10 years from now, you'll say, hey, you know what? This is what we are building.
It's interesting. The analogy that you draw with Windows and kind of the way that the computing environment evolved is the same thing that we're seeing with the clouds. And so if you think back about it, clouds were originally designed to get people off of their on-prem infrastructure. And so by definition, when they were originally created, they replicated in many ways what on-prem infrastructure would look like. And so by definition, you see that manifest in these big centralized models of big data centers, big warehouses. And I think that conversation about monoliths versus microservices makes a lot of sense as well. And I think that from our perspective, it's kind of like it's not an all or nothing proposition. You need to look at what the application is, and you need to make a decision about, do I take that application and break it up into microservices based off of the need of that application? And so what we're seeing is that for the companies who've been in the cloud for a while and are now kind of evolving and taking that next step from on-prem to the cloud to what comes next, Or even in certain use cases, we've seen customers who haven't been able to build their applications or certain types of applications based off of existing centralized architectures, really leaning into saying, okay, well, while it may not make sense for me to have everything broken into microservices, if I'm a gaming company, I may want to push a game engine closer to the user, or I may want to push a leaderboard, or I may want to push stun and turn. If I'm a media company, my live transcoding systems, it probably makes sense to decentralize a little bit so that I can get a better quality experience of stream to the end user. Or things like dynamic ad insertion, that may want to run closer to the edge. And so when we look at the new world and we look at the way that all this is evolving, it really is about saying, let's find the right infrastructure, let's find the right compute capabilities for the specific application, for the specific workload, for the specific need, and recognize that it probably will never make sense for a data warehouse to run at the edge. Simultaneously, if I'm doing ad insertion or I'm doing something with advertising, I probably don't want that running in a core center. And so really it's about how do we create those blends. And so as the industry starts to evolve, I think the recognition of that there are these different layers of compute is kind of the first step. And I think where Akamai is going and where we're looking longer term for Gecko is the next step is, well, now how do I actually make it easy to build applications across all those layers? What's dev tooling look like? What does an observability layer look like? And how do you deal with just some of the dependencies in a multi-cloud environment where our implementation of Kubernetes might not be the same as Amazon's. And so that's where the world starts getting really complex. It's nice to say, hey, these are the layers, but then kind of the next evolution is similar to what we saw in computing. How do we take that step to make it easier for developers to build these edge native applications across this kind of varied architecture and this varied infrastructure environment?
Can you also talk about some of the potential use cases? I mean, there are certain use cases that will benefit from Gecko, but there are certain use cases that will evolve or emerge only because of this kind of model.
Absolutely. So I think, there's some that are probably a little bit more closer on the horizon than others. So in terms of the closeness of horizon, I think we're really seeing a lot of use cases in media, and we're also seeing some use cases in things like IoT and AI inferencing. And I think in those places, what you're really seeing, and even multiplayer gaming, is the idea that in order to reach certain customers in certain markets, I need to be able to get compute as close to the user as possible. So for example, with gaming and game engines, there's this reality where all games are created with what's called a latency buffer. So amount of latency that the game can tolerate in order for the user to be able to still play it. And what we're hearing from our gaming customers is it's fantastic for the majority of markets, but in parts of Latin America, parts of Southeast Asia, they actually can't reach their end users there because the latency falls outside of those thresholds. And what ends up happening is either the user buys it and has a bad experience and churns, or the user just never buys the game in the first place. And so by getting the game engine closer to the user into some of those more difficult to reach markets like we're trying with Gecko, it allows them to attract a new customer that they haven't had before. On the media side, we're also seeing some implications and some use cases in things like anti-piracy. So one of the things that, one of the kind of things that's held anti-piracy technology back in the past has been the introjection of latency into the processing of trying to detect is it a pirate or not. And so what ends up happening is people and media companies often sacrifice some of their anti-piracy or security measures in order to be able to improve the overall customer experience. And again, with Gecko, by moving some of that intelligence closer to the user and some of that heavy processing closer to the user in a wide variety of markets, again, it makes it a little easier to start implementing things like anomaly detection, different types of watermarking technologies. But again, just this like heavier compute that hasn't been available before to enable these new types of use cases. Longer term, however, as we start really looking into the future, when I think of things like immersive retail or spatial computing, or even some of the industrial IoT use cases that we've been talking about as the promise for edge computing for a while, I don't see how those applications run without this new type of density of being able to get really heavy traditional compute pieces closer and closer to the user and kind of getting away from the event-based lightweight computing that's at the edge today. And so, in my opinion, when we start thinking about the promise of edge computing, none of that really gets unlocked until you start having these types of compute primitives running on the edge of your network.
Do you consider that this is going to be a very important shift or paradigm shift when it comes to whole computing, or you see it's just evolution?
I think it's a natural evolution. So I think it's an organic evolution of what the cloud needs to become. From my perspective, the cloud isn't a destination. It isn't the endpoint of what computing looks like. It is just the first step from on-prem to the cloud. And now we're looking at what's next. And I think what's interesting when you start looking at what's next is the hyperscalers, and there's really two ways that this computing world has been looked at in the past. So the hyperscalers have taken what I'd call a very scale up approach, where they created a big data center, and now as they're looking to expand, and you take a look at things like AWS local zones, it's really a big data center approach taken to a smaller data center. And it's just what it is. It's just a smaller centralized data center. And so they've gotten the scale up out, but they're kind of struggling on scaling out. And then if you take a look at what the CDN providers have done in the past, the Cloudflares of the world, the Fastly's of the world, they've really taken and even Akamai, when we first started getting into edge computing, we took a really scaled out approach of, okay, well, we're going to use our existing edge network and we're going to process a lot of lightweight computing instances, but we're going to be able to do it in a lot of locations. And I think what you're seeing unique to Akamai first is this notion of, well, we're both scaling up and scaling out. That it's not just about the scale up capabilities and having lots of heavy regions, or the scale out capabilities and having lots of locations. It's about the combination of the two, of being able to get density closer and closer to the user. I think that's kind of one area where we think we provide uniqueness. I think the other interesting kind of natural progression that Akamai is uniquely kind of positioned to be able to handle is the notion of, now that I have all these different locations, how do I actually create an application that runs across all of them? And if you think about CDN is traditionally the first kind of heavily distributed kind of edge native application. Our CDN runs in thousands of locations. It runs across hundreds of thousands of servers, and it provides a ubiquitous experience to our users. So that notion of being able to build these highly distributed applications is something that Akamai has been doing for the last 25 years. And so that puts us in a very unique position in terms of the, what I'd call the outside in view we have of the world of, great, you have locations. How does your security paradigm have to change? What does observability need to look like? What does your developer experience need to look like? And again, these are the things that we've been building on the back end for the last 25 years, and I think are uniquely positioned to bring a new perspective to the market on how that should be done.
Can you also talk about Akamai's presence globally, so that we can also understand, it's not just limited to a certain region where users and vendors will be able to leverage, but it could be a global phenomenon. Or if you could also talk about, of course, you cannot share a lot at this point, but what are the plans for further expansion of data centers?
Right now, with our core computing regions, we have 24 locations today that have a very big kind of global presence. So we have a footprint across Europe, we have a footprint across our Asia Pacific, and then we also have a footprint across the United States. So that's our core computing locations. With Akamai's CDN footprint, we're in 4,000 locations around the globe today. We are very, very close to the end user. And so what we're doing with Gecko, at least in the first phase, is taking VMs and getting those into our edge pops, so into the same computing facilities that our CDN is running in today, but doing that with an emphasis in more difficult to reach markets. So at the time of the press release, we announced the fact that we're going to be in that we're already in 9 new locations in terms of beta. We'll be adding a 10th by the end of the quarter, and we're targeting an additional 65 by the end of the year, so 75 Gecko locations in total. But when we start going through the first 10, you start getting a glimpse of where we're starting to look to deploy these locations. So for example, in the first 9, we did Hong Kong, we've done Kuala Lumpur, we've done Mexico, we've done Bogota, Colombia, we're doing South Africa. So really, this is when we start to look at Gecko and what we're trying to do, it's to supplement the existing core regions by getting this compute capability into these more difficult to reach markets so that our customers can start attracting end users. But I think that first kind of glimpse of those locations is really it gives you a good insight into how we'll be thinking about the rollout for the additional 65 sites coming in later or towards the end of the year.
And can you also talk about what is your plan to roll out Gecko so that users and customers, when I say users, I also mean end users and your customers, that there is no disruption in not only the way they have deployed things, their own architecture, but the kind of disruption for the services for end users as well?
The way that it would start off with, and what's really interesting is that our design approach, even with the first version of Gecko, is that the APIs and the interfaces and the developer experience that we have for our core regions is the same one that you have for Gecko. So if you have a Terraform integration for deploying compute instances on our core data centers, that same Terraform integration will do deployments on Gecko. So we're trying to make it as ubiquitous as possible to our end users and to stay within the same experience, so that in many ways Gecko doesn't look anything more than just another site where you're able to run VMs. As we get into phase 2 and we start bringing containers to the table, I think that's when you'll see even a continuation of that design philosophy. So we want to make sure that anything that you can build in Gecko actually also runs inside of our core facilities. And so in order to be able to do that, we have to create that ubiquitous developer environment and that ubiquitous experience. So if we're doing things well, and as we roll things out in terms of the experience to the end user and experience to the developer, it should look largely the same.
You also talk about developer experience. Do companies have to change the way they do things, their developers do things, to leverage Gecko, or it doesn't really matter for them?
In terms of the technical piece, it doesn't really matter. A VM looks like a VM. I think where things will change for developers is really thinking about edge native architectures. It's about taking a step back and thinking what makes sense to run, using your term, as a monolith, and what makes sense to actually start breaking things apart. And as you get into that, you may start making changes to the way that you construct or develop your application. So you might start thinking more about microservices. You might start thinking about failover redundancy models. You might start thinking about what does it mean to load balance, and how do I load balance my application across all these different applications and resources and sites. And so on one hand, the underlying, what I'd call technology primitives, will look a little bit, or should look the same, and shouldn't be a big change to developers. I think where the change to developers and to architects will really come in place is thinking through how you build these next generation applications and making sure you're being smart about what you decide to keep running holistically and what you start to break apart. And I think that will, one, require people to change their mental model to an extent, and over time and in the future will likely require new tooling, new products, and new services that may not yet exist today.
You mentioned edge native. What is the difference between edge native versus cloud native, if I may ask?
Edge native is a term that we've actually picked up on. It started coming up and surfacing through CNCF. And it really is a tip of the hat to this notion that future applications should be developed with the notion that there is not one type of infrastructure on which their application could be run, and that some may run into the core, some may run in a distributed, and some may run on the edge closer to the user. And so an edge native application takes into consideration that design philosophy from the ground up. So in many ways, it's a bit of an extension of cloud native, and taking that next step to say, okay, this is how you also integrate more distributed computing layers and more edge computing layers into your overall architecture.
Shawn, thank you so much for taking time out today and talk about this announcement, Gecko. Thanks for all those great insights, and I would love to have you back on the show. Thank you.
Thank you very much, Wabnell. I appreciate being here.